Kia ora and welcome to this video on question 2 of the 2017 Skull Calc exam. Two parts to this. The first part is a question involving a parallelogram, or at least we don't know it's a parallelogram until we work out some stuff. And the maths involved is trigonometry, and then question 2b is a quite nasty system of equations. Okay, part A. They got quite lucky with this question actually, because they give you all this information, and in the second part they tell you that theta is equal to pi over 3. It turns out that theta can actually only be pi over 3. So just before we start with this problem, I'll just bring up a diagram that I've prepared earlier. Here is, I've just tilted it sideways, but here is that rectangle, and all the dimensions are in as the question tells us. It tells us that the height is 3, and it tells us the base as well. At the moment I've got an angle set up at 60 degrees, and everything works really nicely. We go around the diagram, we can see that if one of them's 60 and the corner's 90, so that makes the top angle there 30, and the reflection angles are the same because that's what the question tells us, and we go bouncing around and we get back to where we started, and it turns out it's a parallelogram. If theta is anything but 60 degrees, this actually doesn't work, so I'm going to just move it, and we have a bit of an issue. So if I make it 55.49 degrees and we bounce around the diagram, that last line, if I was to draw it in, wouldn't converge back to where we started, so the shape breaks. And that's the same if it goes over 60 degrees, we end up getting a shape that's not a quadrilateral. So 60 degrees it is. It makes the question actually quite easy if you knew it was 60 degrees, because you can go around and find all the lengths of which they're all fixed. And then, of course, your perimeter doesn't depend on x anymore. It's just going to be a number. But suppose we didn't know that. Okay, so the first thing is we're told APQ is equal to theta, and we're told that AP is equal to x. We are told that AD is 3, so this must be 3 minus x. We're told that AB is 3 root 3. Okay. You need to be able to find the length AQ. If we just go around all the diagram, we've got APQ, angle AQP, BQR, where's angle APQ, equals SPD, so this one's theta, this one will be 90 minus theta, angles have to add to 180, and that one's 90, so this will be 90 minus theta, this will be theta, 90 minus theta, 90 minus theta, back to where we started. Okay, so the length AQ, the tan of theta is equal to AQ over x, so AQ equals x tan theta, and the length PQ, that's cos theta, equals PQ over, we'll call that y. No, hold up, no, we don't want to call it y because it's x. PQ over x, therefore PQ equals x cos theta. Okay, so AQ is x tan theta, and because the rectangle there's 3 root 3, that makes this 3 root 3 minus x tan theta. We've got a whole heap of similar triangles here, but we don't know if, what ratio the triangles are drawn at this point in time, because we don't know that it's a parallelogram. Show that the perimeter PQRS. So at the moment I've got PQ as x cos theta. I then need to find the other sides. There are other ways of doing this problem. I'm just taking the approach of finding all the sides. So SD, what does SD equal? It's opposite over adjacent, so it's 3 minus x all times tan of theta. So we can just say something like likewise SD is 3 minus x tan theta, and SP is adjacent over hypotenuse. Oh, I found a mistake in my trig ratio. Cos theta was equal to opposite over hypotenuse. That's the wrong way around. Oh, sorry, adjacent over hypotenuse. That's x over PQ. So PQ is equal to x sec theta. X over cos theta. So x sec theta. So I'll make this one red. X sec theta. Okay, 3 minus x tan theta, we've got that for SD, we need SP, adjacent over hypotenuse again, so it's going to be 3 minus x times sec theta. For SP, okay, what else have we got? Okay, if we wanted RQ, okay, RQ sine theta. No, do I want sine theta? Or do I want cos theta? We'll go with cos theta, cos 90 minus theta. Cos 90 minus theta, because I don't know the length RB and RC and I can't be bothered working that out, so cos of 90 minus theta is 3 root 3 minus x tan theta all over QR. And cos of 90 minus theta, if you graph that and have a look at it, which I'm just doing, and I've got to be in degrees. You'll find that it's a sine graph. So cos 90 minus theta can be turned into sine of theta. And I'll just show you what I just did there. So I went 90 is pi over 2. So if I go cos of pi over 2 minus x, there you go, it's a sine graph. So I just switch that out, sine theta, and actually I want QR, so I've got QR equals 3 root 3 minus x tan theta all over sine theta. Okay, I can't be bothered writing that one into the diagram, but I've got QR, and then SR is the last one I need to find. I've already got 3 minus x tan theta there, so it's 3 root 3 minus 3 minus x tan theta. And I'm going to use adjacent hypotenuse again to get the SR. So 3 root 3 minus 3 minus x tan theta all over sine theta again. And now the perimeter, I can just add up these things. I've got PQ, PS, and then these dudes need to be added. So PQRS perimeter is equal to x sec theta plus 3 sec theta minus x sec theta. Brilliant. The x's cancel on that. And then we've got plus 3 root 3 over sine theta times 2 the x tan theta over sine theta cancel when I add the last two expressions, and I've got minus 3 tan theta over sine theta. Okay, so that's independent of x. Okay, and then the question says for the second part, if theta is pi over 3 and x equals 2, well, it didn't actually depend on what x was. Calculate the exact length of PR. So actually, if we can, just before I do that, if I can calculate this perimeter using the fact that theta is equal to pi over 3. So we've got 3 over cos pi over 3. 3 sec theta is 3 over cosine, plus 6 root 3 over sine pi over 3, and then tan is sine over cosine, and I'm dividing it by sine, so it's minus 3. Oh, those terms there cancel because they're opposites of one another. Tan over sine is 1 over cosine, so that's sec. Okay, so actually the perimeter is even easier than that. The perimeter is just 6 root 3 over sine of pi over 3. And sine of pi over 3, if I'm in radians, is root 3 over 2, so I get 6 root 3 over root 3 over 2, which equals 12. So it turns out that the perimeter is actually a constant because there's only one diagram that's possible, that's one quadrilateral that's possible for it. So that's also another way of kind of finding it's independent of x. Okay, the second question actually now tells us what pi over 3, that theta is pi over 3 and x is 2. So if we need the x value to be able to find the length PR. Got pi over 3 in there. AP is equal to x, which now we know is 2. And we've got different ways in which we can find the length of PR. We could find the length of PQ here, find the length of QR, find this angle here, and then use the cosine rule to find PR. So let's actually, we'll have a look at doing that. It's AQ, remember AQ is equal to x tan theta, so tan of pi over 3, which is root 3, so this one here becomes root 3. We know AB is equal to 3 root 3, so this is definitely not drawn to scale. It's 2 root 3. Pi over 3 is 60 degrees, so this makes this pi over 6. 30 degrees, that's pi over 6. And then finding QR using that side, adjacent side and hypotenuse side. So QR was 3 root 3 minus x tan theta, so 2 root 3 divided by sine of pi over 6. So sine of pi over 6 is half. So QR is equal to 2 root 3 over 1 half, so 4 root 3. And PQ is equal to x sec theta, which is 2 over cos theta, 2 over cos of pi over 3, which is 2 over half, which equals 4. So that length is 4. Okay, then we have a triangle. It's the wonkiest line I've ever drawn. And we have the angle there. Because on a straight line, pi over 6 is 30, so we've got two lots of 30 is 60. That angle must be 120 degrees, or 2 pi over 3. So PR, using the cosine rule, PR squared is equal to 4 squared plus 4 root 3 all squared minus 2 times 4 root 3 cos of 2 pi over 3. Okay, and cos 2 of pi over 3. God, there's lots of special angles in this problem. That equals negative 1 half. So we've got 16 plus 48 minus 32 root 3 times negative 1 half. I've got 64 plus 16 root 3. So PR is the square root of that. Which comes out to be 9.5767 to 4 dp. I'm just going to check that that answer is right, because from my memory of the question, I think it was actually a little bit tidier than that. Let's have a look. Okay, that's not right, so what has gone wrong? Have I got all my sides labelled correctly? So AP was 2. Oh my goodness, basic trigonometry problems here. tan of pi over 3 is equal to root 3. So this side here can't be root 3. It's root 3 over 2. It needs to be 2 root 3. Oh no, the wrong way around. So this is 2 root 3. Does that work? Okay, it's got to be bigger because 60 degrees means that AQ has to be longer than AP. And then this one will be root 3. So, sorry team, it's terrible. So, what does that make that length there? Root 3 and pi over 6. So it's root 3 divided by cos of pi over 6. This comes out to be 2. Okay, so our cosine rule, oh, have I got that 4 right as well? No, probably not. 4 plus, no, okay, I'm good. It was just that side that was wrong. Okay. So that's going to be 2 squared. 2. Okay, and then get rid of all that. 4 squared plus 2 squared. 16 plus 4 minus 16 times cos of 2 pi over 3 comes out to be 28. So PR equals square root of 28, and that there is the right answer. Okay, sorry about that, team. So it turns out there's actually an easy way to solve this problem. I just went straight to cosine rule because my first method had been involving finding all the sides and all the angles and all that sort of stuff, but there's actually a right angle triangle sitting in here. So if we get rid of all this, because we didn't need it, and just have a look at this sneaky little right angle triangle in here. Now we're told that AP is equal to 2. Okay, and if you remember from working our way around the diagram with those sides, and I'll leave this up to you to work that out, but it turns out that this side here is 1. And we already know that the length AB is equal to 3 root 3. And we can use Pythagoras to find PR. PR is the square root of 3 root 3 squared plus 1 squared. 3 root 3 squared is 27 plus 1 squared is root 28. The only thing that you need to do to make that work for you is find that that length there is equal to 1. Okay, the second question in this video covers a pretty nasty system of equations. In the thumbnail of the video, I graphed the 3 using GeoGebra to show you that there were 2 points of intersection. Of course, you don't need to graph these things in an exam to work that out. Okay, so equation 1, x plus y minus z equals 1. And we're going to be squaring that and cubing that. So that's equation 1. Equation 2, x squared plus y squared. Okay, so rearranging equation 1. Gives x plus y equals 1 plus z, and then if I square that, I get x plus y all squared equals 1 plus z all squared. X squared plus y squared plus 2xy equals 1 plus 2z plus z squared. And then looking at equation 2, I know from equation 2 that x squared plus y squared plus 2xy would be equal to 5 plus z squared. Okay, this is from equation 2. 5 plus z squared is equal to 1 plus 2z plus z squared. Cancel, cancel. Z must equal 2. Okay, so now that we know that z is equal to 2, all the other equations become nice. Because now equation 1 is x plus y equals 3. And if I cube this equation, I've got x plus y all cubed equals 27. Cubing a binomial, I've covered this in earlier videos, but we've got the first thing cubed, 3 lots of the first thing squared times the second, 3 lots of the first thing times the second thing squared, and then y cubed. And then equation 3, because I know that z is equal to 2, I get minus 8 on the left hand side, which I can put onto the other side with the 43 to make 51. So I know that x cubed plus y cubed is equal to 51. Minus 3xy. And then the other two terms, which I haven't dealt with yet, have a common factor of xy and a 3. And I know that x plus y is equal to 3. So I get 51 minus 3xy plus 9xy. Okay, that's using the fact that x plus y is equal to 3. So we make that 3. That gives me that 6xy must equal 27 minus 51. Xy equals negative 4. Okay, and then from xy equals minus 4, I've got x plus y equals 3, and xy must equal negative 4. So solve this system of equations. X times 3 minus x equals negative 4. X squared minus 3x minus 4 equals 0. So x is equal to negative 1, or x equals 4, and y must equal 4 if x is negative 1, or y is equal to negative 1, and remember that z was 2. So there's two solutions. Negative 1, 4, and 2, and 4, negative 1, and 2. Alrighty, now the fact that the x and y values there are interchangeable, okay, we got those x values and y values that we could swap them around, is because of the symmetry of the equations. If you look at the x and y terms in the equation, all of the operations that are acting on it are the same, and it's the z that is a bit different because it's got a minus z in it, so that's not interchangeable with the x and the y. Not a bad problem actually, but the sneaky stuff there of knowing to square to bring in the xy term, and then knowing to cube and factor to get rid of the xy, so the x plus y thing, was what makes that a scholarship problem. Catch you in the next video.